Welcome. My name is John Walicki, and we are IBM Developer Advocates. I am really delighted to be here today to talk about a call for code and climate change. We are going to spend some time today talking about water sustainability and how it affects climate change. We're going to take a look at some of the watershed and pollutants that could possibly cause problems with your water quality. We'll dive down into looking at some APIs with GeoJSON, and we're going to build some dashboards to really show you what you might create as part of a call for code project submission. Hopefully, you'll be able to take some of our examples and fork it and build your solution around it. You still have time to create a call for code solution. The challenge runs until end of July, July 31st. And so if you've not yet started, this is a great way to jumpstart, get yourself going. To tell you a little bit more about Call for Code, I'm here today with Pooja Mistry, and she's going to introduce you to some of the background for Call for Code. So Pooja, please.
Thanks, John. Thank you so much. So my name is Pooja, and I'm a developer advocate at IBM, just like John. And I wanted to talk to you guys a little bit about the 2020 Call for Code Global Challenge. So I'm going to just share my screen a little bit, and that way we can kind of dive right in. So you guys may be wondering, what exactly is the Call for Code Challenge? So the 2020 Call for Code Global Challenge is a global hackathon that is calling on all developers, innovators, around the world to build solutions that fight back against both climate change and COVID-19, which are some of the world's most pressing problems today. To get started, you can register free on IBM Cloud to receive regular updates that will arm you with new skills to help you accelerate your development. The truth is that we no longer can ignore that our world is in a state of diminishing return. We're seeing the impacts of our own action. As noted by Antonio Guterres, the climate change crisis is caused by us, but there is still an opportunity and a window of time to right our wrongs. And we can do this through technology. The moral obligation to halt and reverse the statistics shown here is at the highest level of urgency, and the UN is demanding a global reality check, and that's where we need you to help us solve some of these problems. The global survey has revealed that 77% of developers and first responders say that climate change is one of the most pressing issues in their generation. To tackle such a issue like climate change, the first action is to address some of these highest priorities. So you can think of these in three aspects. So with greenhouse gases infiltrating the air that we breathe at alarming rates, we must recognize that our energy methodologies are currently in place are the dominant contributors to climate change. Therefore, energy sustainability, thinking about that as one of the solutions is definitely something we must think about. And while there are many repercussions that we will have due to climate change, water issues are incredibly highly at risk. So thinking about water sustainability as another aspect is something that is another idea to think about in terms of a solution. And finally, environmental shifts such as rising temperatures and natural disasters continue to extend in frequency and intensity. How many more flooded cities, forest fires, and state of emergencies can we truly endure as a world? So thinking about issues around how to solve disaster crisis problems, these three areas, energy sustainability, water sustainability, and disaster resiliency, are some of reality's most pressing questions, and that's why IBM is uniquely positioned to offer you an opportunity to find the answers. In this session, John's going to be talking a little bit about his take on water sustainability through a starter kit to inspire you all to think about a solution to these challenges. So here are some potential use cases where you and technology can make an immediate lasting impact around the world. By leveraging AI, IoT, blockchain, you can harness the power of data to construct trends and pinpoint areas to reduce energy consumption. You can use IBM Cloud, open source development platforms to address the threats on our water. You can also lean into machine learning capabilities to devise hardware and software solutions to reduce toxic exposure and improve preparedness of natural disasters. So when it comes to 2020 Call for Code Global Challenge, every idea to bring a change for the betterment of our world is an idea worth exploring. IBM Developer has also created some starter kits to these solutions that are worth exploring while you start your Call for Code journey. So I wanted to talk to you about a little bit about some previous Call for Code winners. So the Call for Code 2019 Challenge Prometeo team developed a first of its kind hardware solution equipped with sensors that detect toxicity levels for firefighters battling wildfires in real time, which offers a really transformative first responders solutions globally. And in 2018, Project Owl created a groundbreaking hardware solution that automatically constructs a mesh network via Wi-Fi units, allowing for sustained communication in peak times of need. Both of these teams received $200,000 in awards, open source support from the Linux Foundations, meetings with mentors and potential investors, and finally, they were able to implement their solution with the support of Code and Response, which is a team of IBMers that are there to help bring some of these ideas into reality. So these teams answered these calls and they were able to achieve so much through the Call for Code Global Challenge. However, it's not just the winning teams that receive these awards. Call for Code contributes to ideas that transcend just the winning teams. Solutions like P3DR and DroneAid offer alternative ways to combat natural disasters and adversities that have received Linux Foundation support to make these solutions bona fide answers to environmental hardships across the world. So there's another track that I wanted to talk to you all about, which is the solutions for the COVID-19 track. So the COVID-19 track was added in addition to climate change this year with the unprecedented effects of this global pandemic. So with those unprecedented effects, we must unite to act swiftly to combat what has the potential to become one of the greatest crises in modern times. So if we think about how can technology help something like COVID-19, well, there's a massive list of issues that need to be solved. And three issues that we at IBM have pointed out are around crisis communication, remote education, and community cooperation. So these three issues, whether it's addressing communication systems that are the first to become stressed, or the comprehensive shutdowns of schools worldwide, or just calming a community to build a steady headspace and steady procedures for communities to follow. These three are particularly some solutions that can help a pandemic like this through technology. There are starter kits available for crisis communication, remote education, and community cooperations that are available at developer.ibm.com/call-for-code that can help you get started with these kits. So be sure to check out all of these resources for both the COVID-19 track as well as the climate change track when you're on your journey. But by now you must be thinking, how do you get started and what are the deadlines? So the deadline to submit your final project is by the end of this month, July 31st. Whether you need to find teammates, meet experts, or ask questions, there's a community that's out there for you. You can check out the Call for Code Slack channel to find teammates and submit a project from a hackathon that you've participated in. Ideally, your goal is to have a sustainable open source project that can be deployed quickly and scaled around the world. Whether you're ready to submit, When you're ready to submit, be sure to provide a link to public source code repositories such as GitHub, along with a 3-minute demo of your application. Submit this with your participation agreement, and you can, be in a running to win, with a chance to win $200,000, as well as a chance to make your solution a global reality. So I hope you all get started with this challenge today. We need developers and innovators now more than ever with all of these rising issues. And so if you do decide to get started and you have any questions, feel free to reach out to either John or I. And with that said, I'm going to hand the screen all over to John to share his idea on water sustainability and the water crisis as well. So thank you.
Thank you, Pooja. So I, too, want to join the fight. I encourage everyone to join us. So I'm going to share my screen, and we're going to spend the next 40 minutes talking about water sustainability and climate change. And so let me just find my screen. Maybe that one sounds good. So if you don't yet follow me at John Walicki. I am at home. And so I jumped over to developer.ibm.com/call-for-code, and I want to join the challenge. So I jumped over, like Pooja suggested, to get started. And I noticed that the climate change track really captured my interest. And I saw that the water sustainability was one of the themes in climate change. So I read a little bit about it. And I went and I did some interviews with some subject matter experts, and today's talk is about what I learned from some of the experts, and then I took their guidance and I started to build some solutions. And we'll actually go through, as a developer, what I created, what maybe you could create too. Take my code, it's available in GitHub, and you can start to build on top of it. And so as I learned about water and water sustainability, one of our partners is the United Nations. And they've issued a whole set of calls for action for all countries and developers to come and try to fight back on climate change, and particularly water. And so I read through the sustainability goals, and I said, well, maybe there's something I can do here. It's a rather personal story for me. Now, I live in New Jersey, and we have access to good water, but New Jersey has a long history as part of the Industrial Revolution around contamination. And it's not a joke that New Jersey's got lots of Superfund sites. And so I worry about the water quality here in just New York, New Jersey area. And so I found some experts from Aquajuinity, and they've got a website that you can go to, and you can type in your zip code and get a report about the water in your community. And so they've got a test kit that you can buy and get your own results from your own tap, or you could just look at some historical data. And so that's what I did. And they came and presented to us, and I learned a lot about water sustainability in your local community, and encourage you to visit the Aquajuinity website and explore your water quality. So I entered my zip code and I got a report, and it comes back with all sorts of contaminants that are potentially in my water. Something that I worry about as a father of a family. I worry about my children and what they're drinking, and they're very health conscious. So we want to make sure that all the things that are possible contaminants we can filter out. Got a filter system for the home, and I worry because in Ridgewood we've got a long-running community campaign to go encourage the local water utility to improve, and so very personal for me, and I was, so I'm sort of impassioned about this, and you'll see that in my developer experiences as I build my solution. But I also know Ridgewood is a small community of 25,000. There are much bigger water sustainability questions around the world. As a citizen scientist, I'm always interested in the Catskill reservoirs and the aqueducts leading down to New York, Tunnel 1, Tunnel 2, and the forever building of Tunnel 3, billions of dollars. And I went and I talked to, turns out, the Atlanta City Watershed Department, and we had some wonderful conversations with the watershed team there about their water quality, and they're doing amazing work to keep the water quality in Atlanta high. And they sent me some details about how they get their water. So they get their water from groundwater, so rivers, streams, upstream. It rains. They've got a couple of reservoirs. The water flows down the river, and then they bring water out of the river and they do some filtration and they serve the community in Atlanta. So they've got a number of watersheds that serve their community, and so they are very interested in protecting the watershed, as is New York, right? They invested 100 years ago in a variety of reservoirs north of New York City in the Catskills to bring fresh water down. So I saw the map, that was really interesting. And because I'm also interested in water, so in Ridgewood, this is a little map of Ridgewood I just switched to. For years, you'll notice that in one corner, I've got the Hohokus Brook, and in the other sort of lower right corner, there's a Saddle River. And my house is sort of in the middle of this, down close to the hospital here. And no, I'm safe. My house doesn't flood. But years ago, Hurricane Floyd and a couple of hurricanes came through and flooded both rivers. And I was worried about my neighbor. So I had my mobile phone, and turns out the U.S. Geological Survey has a number of flood gauges sort of upstream, very close to my house, where you see the two pins. And I can get data from the two pins, and I can set up alerts on my phone when a flooding event might occur. So I subscribed years ago, and when it rains, I get an alert when the rivers rise. So I've got Hohokus Brook, and you can see that the Hohokus Brook sort of goes up and down on a daily cycle. Then next to me is the Saddle River, and you see that it rained a couple of days ago on July 4th, and then it rained yesterday. Big thunderstorm passed through, and so the river rises. Now that's not a flood; it's just moving river at this point, and then it subsides and things are fine. But when you think about what's upstream of this, you need to go and think about, how do we know what's in our water? And sometimes you have to look upstream to know what's in your water. And so it turns out they've got some really cool maps that you can go and query. So there's my house, sort of Ridgewood in the middle there. That's one of the flood gauges that I care about. The Hohokus Brook and the Saddle River come together at a little tiny waterfall, and there's another flood gauge down by the orange dot. And you can get water flow rates and flood gauge details. So that was kind of cool. And I read this little link down here about the Network Link Data Index, and turns out there is an API underneath this. So I'm like, that's super cool. Let me go take a look at this NLDI web API. And I'm kind of interested in it because if I can query the data instead of the app sending me alerts, I could go build my own alerting system that gives me chances to build solutions for call for code, or maybe write it into my little home automations that I have around with Node-RED. And so I jumped over to this API, and turns out there's a Swagger document that I can go and read about the various, getting the details from how to navigate what the water basin looks like. Each one of those gauges has an ID. So if I know my ID for the Hohokus Brook and the Saddle River, I can use this API to go and query data. And so that's sort of what I did. And I figured out how to use it. No API key required. It's an open data set, public resource from the US government. And I started to experiment. And so I built my first little string here. And as I'm reading the docs, I'm learning that it's returning a GeoJSON object. So those of you that are developers, JSON is a JavaScript object notation format. It's similar to XML and other query formats, data formats, pretty straightforward to parse. And GeoJSON returns a whole set of geometry and features. You can draw pins, and you can draw lines and polygons and multi-polygons, and you get longitude and latitude back. So I did that so here's the URL or the location ID for one of the brooks, the Saddle River. And as I fill that in, I get back a whole set of longitude, latitude. It's a polygon. And I'm like, that's interesting. What can I do with this JSON object? And it turns out that many maps online can render an area map. If you give them GeoJSON object, you get back draws a map. And so it turns out there's a Node-RED contrib web world map that if you give it so I read the docs here, and so it turns out I reported a bug or two, and just recently they fixed it for me. And so I wanted to send a GeoJSON to the web world map and fill in and with some color and some background and some highlights and drop some pins. And so that was kind of clever. I'm like, that's super awesome.
So
let's go see what I could build with this.
You were able to take public data and then convert that into GeoJSON and then use that within a Node-RED contrib node, correct? I just wanted to...
Yes, that's where I'm going with this, right? So I kind of string this all, my interests around water and my watershed with, as a developer, an API and some formatted data from the US Geological Survey. And then a really cool node in Node-RED that goes and renders that as a map. So let's go take a look here. And I kind of jumped ahead. Hopefully, I'm going to refresh so you don't. Too bad. All right. So let's go. So here's a map of New Jersey. I'll zoom out for a second to give you some context. So there's New York. Here's Manhattan. You sort of see Manhattan in the middle there, and so Ridgewood is a suburb 35 miles away from Manhattan, and a great community to live in. The water's not great though. And so let's go take a look at, here's a map of Ridgewood. And so what I did there is I sent the map, the area of Ridgewood, New Jersey. Turns out the internet is amazing. You can go find the GeoJSON object for just about anything. So they've got towns and counties and states and all this geocode location information, longitude, latitude. And I give that to the map service, and it renders a nice little map of Ridgewood. And kind of clever. I picked maroon. It's the high school colors. One of my daughters graduates tomorrow from Ridgewood High School. And so I had to do that in maroon. And then I wanted to go call those APIs. Remember the geocode area map for the watershed. And so I wanted to go, let's go take a look at the Hohokus Brook water basin. And so that's the drainage area for the Hohokus Brook. And so it rains, it is a couple of streams, and maybe there's some hills, and as the rainfall runs down the hillsides, it goes into a stream, and the stream becomes a little brook, and the brook flows through my town. Same thing with the Saddle River. And so these are small watersheds that flow through Ridgewood, New Jersey, and flood occasionally. During Floyd, it flooded City Hall and wrecked all the police cars. So that was kind of not a good thing. So you would want to have alerts. And I learned about this. I thought that was kind of neat. Now you know where your water comes from. That's the first step. Then you want to know what's in your water. And that's when I turned to the AquaGeoinity website. Remember, I showed it to you and I just typed my zip code into their webpage and I got back some results. Well, it turns out they have an API that you can go and request an API key for. And so I typed in my zip code and I'll press submit. I've sort of tipped you off that I'm going to get some results here. And I get the results and I drop a pin on my map, and I got a table here of all the contaminants and toxins. And so I looked at this, and first it's just a big JSON object you get back from their API. And I'm looking at it going, the EPA limit says it should be, 4 micrograms, and here we are double that, or whatever it is. And so I went and I'll show you the code in a couple of minutes. I wanted to go highlight the ones that were out of compliance because of the Industrial Revolution and pollutants upstream, not recent pollution, 100 years ago pollution still seeping out of the watershed and out of the aquifer. And so I kind of said, wow, that's a little scary, right? So this one, whatever chemical that was, kidney, liver problems, increased risk of cancer. Love New Jersey. It's a great city, great country, great county. So I scrolled through, I said, yeah, that's just not good. So I put a bunch of filtration systems in here, and I built a little bunch of alerts that tell you what the damage might be and health risks are.
It's interesting that you could take both like GeoJSON data as well as the AquaGeoinity data and merge them together to build such a filter using these tools. Like, it's interesting that you were able to build those two filters as well. So with the GeoJSON data, was that able to map the rivers as well? Is that part of the data?
Yeah, let me show you. I'm going to zoom in. I'm not sure if you can see it, but here, I'll just clear them off and let's just look at one.
So I'm able
we'll
to
look at the
lines.
smaller one. Do you see the blue lines?
Yes.
In there?
Yep.
Yeah, so the watershed, the area map is a dark blue line, and that's sort of just where if the raindrop were to fall, which stream would it go down? But there's another API in there. There's actually 2 calls. The first one gets me the basin, and the other one gets me, well, they call it navigation, but you'd have to have like a canoe. There's no motorboats on the Hohokus Brook. Maybe a canoe. It's 5 yards wide or 5 meters, 10 meters wide. But you could canoe up the river if you so choose. And so when I drew this picture here, there's actually 2 calls. The first call gets me the watershed basin, and the second call gets me the river itself.
Okay.
And so that's the light blue and then the dark blue.
Oh, okay. So there's definitely 2 API calls that you're calling to overlay both the basin as well as the river, correct?
Yes.
Okay.
Yeah, pretty clever, right? And I'm going to show you the code in a couple of minutes because it was awesome fun. But I got some more stories to tell, right? So I'm still kind of at that water sustainability. What does this mean? And so remember I told you about Ridgewood Water Utility, and there's this ongoing community challenge to go and encourage them to invest more in filtration and testing and public disclosure, transparency. And so they do now have a whole set of reports that you can go and read about on their webpage to learn about what's in your water. And there's a link here that says, other than me go pay my bill, you can go get water quality. There's a water quality link here too. Conservation and water quality information there. That's what I was looking for. And so you can go and get yourself reports on some of the chemicals. And so with public pressure, the water utility is investing to make it, make their water better for the community residents and I. And so that was encouraging. Certainly not there yet, but they're on their way. Because if you really were to look at some of those Superfund sites, so Ridgewood, over the last 100+ years, there's been gas stations and dry cleaners and industrial manufacturing sites that they've identified that are 32 different sites. And we're not alone. There's lots of contaminated sites in Bergen and throughout Bergen County, being the county in Ridgewood in New Jersey, but there's many others with Superfund sites. And so I started to read about this, and turns out there's quite a few. There's New York, and remember I told you about the Industrial Revolution. Now the heat map here is where those contaminated sites are, and I sort of live over by the 17 number, if you can see that on your screen. And so we've got some upstream. Remember where the watershed is? Are some of these sites that have contaminated possible damage? Not new, right? Old sites that have been remediated or try to be contained. So it's good to be an informed citizen. And so I do follow the New Jersey site remediation sites. So I don't want to scare anyone. Ridgewood is a great town. It's got a great school district and all of it. But you got to know what's in your water.
I'm curious because my hometown is the birthplace of the Industrial Revolution in America. So Lowell, Massachusetts. So I'm wondering how the history of industrialization has changed that town as well. So what you're saying is that you could basically take the data from any location to kind of find this information.
Yes. So I'm going to tell you a little bit more of a story. So I did this for Ridgewood, and I already knew those two because I can go and see them. I knew where the flood gauges were, and I found the location site ID. But remember I started to tell you the story about Atlanta and how good of a job they're doing there and how big their watersheds are. Well, there's another resource up on the USGS website. You can go and find, I won't take you there because it's like a giant table of CSS data, kind of boring. But I pulled it up and I did a bunch of searches across thousands of records in Georgia, looking for watersheds, Peachtree Creek, and so forth. And eventually I found the right gauge and site ID that I could draw the map. And if we knew your town, Lowell, Mass, we would be able to look through and they've got some nice graphic user experiences. You can drill down or drill up. Somewhere here. Thank you for asking, Pooja. Everyone can go and do it. Actually, the fastest way is to go look at the Saddle River, and you can, I think, jump over to look at some of the details. I was there just the other day. Maybe if I just do this. There's a link and you can go to water data. I'm losing track here, Pooja. Not really sure where it is. And I can we can find the watershed for you in Lowell, Mass if you're interested.
Yeah, for sure. So it's
Okay.
cool that you can get it from whichever data. It's not, it's, it's very limited to the user's preference as well.
Yeah, yes. There, it's this one. You have to now I don't know too much about Massachusetts, and there's some way to search here.
Mm-hmm.
They've got some really cool resources in the USGS. These geo, and I'm not a geophysicist or anything by any means. So you could go search on this website, Pooja, for your hometown.
Cool.
And get details. Yeah, it's pretty neat.
Yeah.
All right, let's keep going on our journey because so that's US data. But we know that call for code is a global challenge. And there's another website that I learned from the Nature Conservancy team. I went and interviewed with them, and they had some amazing open data sets. It's called hydroshed.org. And you can not only look at US data, but they've got Amazon basin, right? In Brazil and the tropical rainforests. We're all worried about climate change related to keeping those Amazon, sort of the lungs of the planet, alive and healthy instead of being burned down for cattle grazing. So you can go learn about the Amazon water basin at hydrosheds.org. That was pretty cool. And so there's lots of data sets that you can build your solutions with GeoJSON and maps. Kind of awesome. All right. So, hey, let's go look at the code. Want to go look at the code for a bit?
Yes, let's do it.
All right. All right. So remember, so this is Ridgewood. I'll make that a little bit smaller so you all can see. How's that? Not too bad. All right. So I've got a couple of buttons. Remember, there's a toggle switch for Ridgewood and Hocus Brook and Saddle River and a form to fill in the zip code for my water quality. And oh, Pooja, we could type, if you remember your zip code, we can type your zip code in for Lowell, Mass. We could go do that. But so if I turn on Ridgewood, there's a switch if it's true or false. And then I wanted to draw the map of Ridgewood. So this is just hard-coded static data of what the Ridgewood, New Jersey location looks like. And I found this on the internet. It was nothing fancy about it.
Yeah.
And I passed that to a function node, and I basically build myself. I wanted to be a color, so I called it maroon because that's the shape and fill that I wanted. And I gave it a name, and I loaded up the GeoJSON, and I passed that. That's it. I pass it to, remember I had this super cool node called Node-RED Contrib Web World Map, and I went over to my palette here, and I installed the world map nodes. And so I took one of these and I dragged it out to my palette. And so I called it water map. And I wanted it to zoom in sort of on Bergen County. So I typed in some geo codes. I picked the zoom level. I picked a map. And that's it. It drew a map for me. It was like, whew, that's super simple.
That's awesome.
And then I did the same thing for Hocus Brook and Saddle River, but now I'm going to go call the USGS data. I didn't need an API key. It's sort of open. And I first I wanted the river. So that's the navigation. So if I had a canoe, I get back from this command here. some GeoJSON. It looks like this. I think we're looking at Hohokus. It's this one. So I get back and I pass it, a bunch of coordinates. All right, everyone memorize these. They're down here somewhere. And so you can pass that detail to the map, and it draws the river. And then I did the same thing for the water basin, and I draw the map for that. Now the only tricky thing I did here is I had the on and off switch, and so there's a node where I can tell the map to hide the data. And so I just basically tell it to do remember I gave it a name, and I tell it to just do hide layer. And that's basically telling the map to not render that particular GeoJSON anymore. And so that's how I can toggle it on and off. Okay. While we're here, let's type in the zip code. What's up in Lowell?
Sure, it's 01854.
Let's take a look. All right. Oh, nothing. Maybe there's a bug. Oh, we'll have to debug that. Let's go see what we got here. On the bottom here. I'm always interested in the challenge. Or maybe there were no results. It's also possible. The entity doesn't have everywhere. So we got back a water score. Yeah, so there were no results for Lowell.
That's so interesting because there's a huge river that flows through the city, the Merrimack River, which comes all the way down from New Hampshire, which is interesting.
Yeah, so you could buy yourself a kit and tell your parents to test the water.
So my question to you, John, is like, you have these APIs, so how do you go about testing them?
So I do a ton of unit test. Now I showed you this sort of end result with the AquaGeoInity test sort of built into it, which I didn't yet narrate, but down below is, you type in your zip code and you send it a bunch of secret parameters in my API key, and then I call, this is an HTTP request node, and I go hit their API, and I get back a JSON object, and I take that and I build a little contaminant table, and I turn some of them red depending on whether the toxin exceeds the EPA limits or not. And then I pass that to a table, and then if I click on the table, I show a little dialogue with what the health risks were. And so this section of code here does sort of what I've figured out. And so your question is, how do you test this? And so I often, with Node-RED, build test harnesses. And so I have another tab in my app here. It's called AquaGeoInity Test. And I just have an inject button, and I've set a parameters because they gave me an API key. And let's go see what it looks like. Let's go and if I just go test it now. So I passed it an auth object and a zip code. It responded. So when I hover, so I get back a response with a bunch of headers and a water score. And it looks like it's an array. So this is an array for Ridgewood. And these are all the contaminants, 57 contaminants in my water. And now I get details for each contaminant. And I can click through. And now I didn't want to show you all of them. I just showed you sort of the toxin name, and then what the health risk was, and what the quantities were. So the EPA limit and the sort of what the test results were. And so I got, and all I did here was a set of debug notes, because I wasn't trying to do anything except for experiment with the API.
Right.
And that's sort of how I do a lot of my testing, Pooja. Good question. I kind of build little samples. I poke through the JSON response and I parse out. I'm like, ooh, that's interesting. Let me put that on a map and drop a pin, right? Because I want to drop pins.
Nice.
I did something similar. Well, I was using the Here APIs. We've got a great partnership with Here, and you can give them a location with their API key, and it will turn a longitude and latitude. And so I used a Here API for that.
So
Not in my particular flow, but here's another example that I built. Okay.
So would you advise like new developers who are getting started to basically test similarly like this? When they
I encourage, yes. So yes, test, unit test. I don't write hundreds of lines of code and expect it to work on their first try. I write a little chunk of code and I test it out, and then I write a little chunk of code and I test it out. And it becomes a program over time. I sort of have a vision of where I'm going with it, but I build it incrementally with a whole set of smaller steps, one by one, through unit testing of just experiment with an API, experiment with drawing on the map, experiment with how I want the user experience to be, and then at the end it all comes together in cute little dashboards. Should we keep going?
Yep.
All right, cool. Let's go take a look at this. So now I knew about Ridgewood, and I had talked to the Atlanta City Water Department. They've got 8 million people in Atlanta. And so here's a map of Atlanta. And it turns out remember that PDF they showed me? They had a lot of little watersheds here. And so I'm going to draw a few for you. And I gave them all terrible colors because I'm not a designer. And so I picked some really random colors here. And so there they are. And each time I clicked on one of those switches, I drew a map. These are the ones I could find. So there's some big watersheds here, and they got a really great reservoir upstream of Atlanta, right? So Atlanta's sort of there, and they've got some really good water quality. So let's go take a look. So I think this is Rex or Decatur, somewhere close to Atlanta. And so check this out, Pooja. They are in really good shape. They had like one or two, three. That's like three. And copper is easy to filter.
Yeah.
That's not a terrible thing. That's sort of natural. That's not you would just find it in any granite-based type of stuff. So their water quality, the watershed team in Atlanta is just doing a bang-up job of maintaining the watershed and the quality of the water there. They invested in a quarry, an old quarry that they filled in with water. They built a big water pump. It holds billions of gallons of water in some quarry, and they pump the water out of the river. They filter it and they store it in a quarry as a reservoir, and then as they or a trout, they have a big water supply to pull from. So I did it for New Jersey, and the team in Atlanta clearly is doing a good job of maintaining the water down in Georgia.
I think we have a question from Safia who finds this really amazing. One question that she had is, can you use 2 API keys while analyzing this information?
So yes, so that's what's really fun about writing applications with Node-RED is you take all these different APIs and you smash them together. It's an event-driven programming model. And I'll just go to the Ridgewood example. The Atlanta example is sort of exactly the same, except for it's got a lot of copy paste as I went and looked for Nancy Creek and Peachtree Creek. And these are just API calls, Sasha. And so I make, when I turn on the switch for the Peachtree Creek, say that fast, Peachtree Creek water basin, I actually make 6 different API calls to the USGS, and I get back a whole set of responses. And at that point, I go send the different data to the map. The map figures out how to render it asynchronously. So it doesn't matter. I can hit it with, thousands of requests. In my case, a couple of dozen, no trouble. So yes, you can write applications with lots of different API keys, smash them together. I build mashups with all sorts of APIs.
Right, and you mentioned that the map rendering, you use 2 APIs that you laid together to get both the rivers and the basins. So
right. So the first one, let's go Peachtree. So this one gives me the navigation, and so that would be like the river itself. And then the next one gives me the water basin, which tells me the area for which the water is drawn from. So if it rains, it goes downhill, it goes into a stream, into a brook, into a river, downstream. And so I have 2 calls. So there's 2 different API calls, and I get back 2 different JSON objects, which then I pass over. I build, whatever color I wanted it to be. I wanted it to be steel blue in this case. And so I pick a color and then I pass it to the map. I call that one Georgia water map. So that was sort of how it works. Kind of fun.
awesome.
All right. So let's go wrap up here. I got a couple of small little stories. So if you want to go build this, I put it in my Git repository. And so if you go to github.com/John Walicki, you will find a repository called Node-RED Water Sustainability Dashboard. And I'll take you over to it. And it has essentially, you can go to the flow and paste it into your Node-RED dashboard. And I took some screenshots of New Jersey and of Atlanta. And what you saw, I just showed you, is some screenshots. And the code's all available for you to go and experiment with right here in the Git repository. Okay, so just copy that to your buffer and paste that into your Node-RED flow, and you get this. So that was neat. So go take advantage of my code. All right. I wanted to talk a little bit more about flooding and other disaster responses, because one of the things that we encourage developers to do is listen on social media for where flooding is occurring. So if you knew about your map and there was a severe weather report, you could go, oh, by the way, I've got another really cool repository called Severe Weather Maps. And this one uses the Weather Company API in conjunction with the National Weather Service to go and map out all the severe weather alerts. And you get back, you go hit that API endpoint, and you get back all of these wherever in the US. I think also data from Australia and Europe as well. You get back, you go call the Weather Company API, and you get back a whole set of data that you can do alerts. All right, so if it was flooding, so severe thunderstorms, You can get a severe thunderstorm alert. And you could, of course, would overlay that with your water stream data so you know whether it's going to flood or not. But I also wanted to listen on social media. So I built another program called my Node-RED Twitter workshop. And I have a fun one here. It also has a map. I'll scroll down to it. I'll show it to you. And I wanted to listen to the sentiment of whether people were happy about floods or not, usually not. And I dropped the data on a map here. So we're going to go take a look at this one live. And I've been following, so there it is. I turned it on. So on Twitter, I've got myself a developer key, and I'm following hashtag flooding. And I turned it on a couple of hours ago. And I'm going to drop the tweet data on a map like I showed you earlier. Looks like this.
Oh, wow.
Oh, maybe it's a little too big. Maybe smoke that a little. Oh, not that one. Sorry. Here. There, that fits now. So, as I get the tweet, hashtag flooding, and so the sentiment for this particular one in Japan has killed 55 people. That's terrible, Pooja.
Yeah.
And so the sentiment is -3. And so over the last hour, you can see that maybe one positive one, but most of them were negative.
Right.
Because no one is ever happy about flooding. That's a -5, whatever that tweet was. And I go and I drop them, because remember, you get, as part of the Twitter metadata, if you allow location,
Yep.
you can
See
you
where
get
that-
GeoJSON. Sorry, just longitude, latitude, and you can go and take this sentiment, and I just color the pin. Neutral is gray, green is positive, red is negative. And so here, it looks like 75,000 people in Japan have been ordered to evacuate. And so that's sort of the news right now in Tokyo. And I got that just from dropping a pin on a map. And so that was kind of cool.
Wow.
So that example's also available in my Git repository.
That's amazing. So
All right.
I have some questions for you, John. So, you've definitely built some really amazing dashboards that provide a lot of insight, on a lot of world issues. What advice would you give, developers that are planning to take this Call for Code challenge, on how they can get started, how they can think about data differently, and what advice would you give when they're starting the ideation process?
I encourage everyone to search maybe out on the internet for other examples. Open source is great. And one great part of open source is you can learn from others, build on top of their ideas. And so I do that with all of my work. I post in GitHub because I encourage you as a developer, go find my stuff and fork it, start if you think it's any good, and build something amazing with it. I build these examples so that others can build better things. And so first of all is use the resources available to you. Don't talk to experts. I had the great opportunity to talk with the Aquagenuity team, to talk with the Atlanta watershed team, and learn from them. And once I learned from them, then it became very personal for me to go build the story. And the tweets are just coming in fast and furious here. So go talk to experts.
Awesome. And where would you find
All right.
these starter kits? I think they're on developer, correct?
Yes, I've got a number of resources if you go to get started. There's a couple of other ones. So if you're looking for other data sets, Charity Water, they've got some like amazing uh there's Ethiopia water quality data. This is super cool. I looked at this. I didn't know what to do with it, but I thought it was awesome. So this is Ethiopia, and they've got sensors in Ethiopia kind of telling you what the water quality is. So if you want a global project as opposed to something close to home, like there's flooding in Ridgewood, you
Mhm.
can build some amazing data using charitywater.org.
Wow.
So jump there. But we're going to wrap up, and so I encourage everyone to get started. Go to call for code / get started, and then accept the challenge. Come up with decide whether you're going to do climate change or COVID-19. Know the dates and the submission process. Build a team. We've got some great Slack channels that you can go and join, find a team, form a team, ideate around your idea, take advantage of some of the starter kits, and then
And
submit your solution.
oh,
$200,000, Pooja.
for sure. And I feel like there's so many people out there that have done amazing hackathons throughout the year. I know we're doing everything remotely right now, but if you feel like your solution hits on some of these issues, feel free to submit and work with your team at hackathons. Those are the best way to ideate as well. So for sure. This is great.
Really enjoyed our conversation today, Pooja. So
Yeah,
thanks everyone for joining. We've got a couple more weeks, so get your submissions in.
sounds good.
Thanks, everyone.
Thank you, everyone.